Okay, so we finally made it to our last video. I know this was kind of a lot for tonight, so thanks for sticking with me. All right, so we're going to look at some functions with key features. So let's look at that linear column first. The equation they gave us was y equals x. That is a linear function, straight line, positive slope going through the origin. So the domain for linear functions, this is actually true of all linear functions, is all real numbers. So we express that negative infinity all the way to positive infinity. The range is also all real numbers, so negative infinity to positive infinity. Okay, just zoomed in, that might make it easier to write. Okay, so increasing, this particular linear function is increasing the entire time. So it's increasing from negative infinity to positive infinity. Where is it decreasing? It never has that negative slope, so it's not decreasing anywhere. The x-intercept and the y-intercept are both at the origin. So x-intercept is 0, y-intercept is 0. Okay, so let's look at some key features for this quadratic function. Quadratic functions have axis of symmetries, and if it's just y equals x squared, the axis of symmetry is the y-axis. That's a line of symmetry that cuts your graph in half. So that's good to know about that. The domain. So domain is your input values. What can you plug into your x and then square it? You can square every single number. So the domain will be, again, from negative infinity to positive infinity. The range, however, if you square all your numbers, and what kind of outputs do you get? You get all positive numbers. You don't square a number and it turns negative. So it's all your positive numbers, but think about 0. If you square 0, you get 0. So your range includes 0. So it starts out at 0, and then you'll have all the way to positive infinity. You'll grab all those numbers. This function is increasing. On the right side, here's where it's increasing. So from 0 to positive infinity. At 0, though, that's that neutral point in the middle. It's not going to include the 0. So from 0 to infinity, it's increasing. It's decreasing, and you look from left to right. So from left to right, it's going down, starting at negative infinity all the way to that 0 without including those endpoints. X-intercept and y-intercept for this particular one is at 0. It's at the origin for both of those. Okay, we're going to move on to our next function, our absolute value. We have y equals the absolute value of x. I mentioned in an earlier video, these are V-shaped graphs. Because the absolute value of x has a positive in front of it, that's why your V is opening up. This one also has an axis of symmetry. Going through the y-axis. It's a symmetry line that cuts your graph in half. So domain, what can you plug in to x, your input values, and take the absolute value of? Well, everything. So all your real numbers from negative infinity to positive infinity. The range, however, what's your output when you take the absolute value of your inputs? They're all going to be positive. And then just consider 0. What's the absolute value of 0? It's still a 0. So we include 0. That's our smallest value, and it's going to go all the way to positive infinity. Okay, this function is increasing here on the right side. It's going up from left to right. So we don't include that 0 in the middle, the neutral. So it's increasing from 0 to positive infinity. And it is decreasing from left to right, going this way, from negative infinity all the way to that 0. And again, we're not including the 0, which is why we have parentheses versus brackets. The x and y intercept for this particular graph is at the origin again. So x-intercept is 0 and y-intercept is 0. Okay, last one. Your constant function, in this case, your example is y equals 1. So your domain, it's going to hit every single x value. So your domain is all real numbers. So again, we'll do from negative infinity to positive infinity. Your range, however, what y values, what's your output going to be? Well, it's always going to be a 1. Your y will always equal a 1. So we'll use the set notation for this one. Your range is all the y such that y is always going to equal 1. Increasing or decreasing, well, it's constant. It's not increasing or decreasing. It doesn't have like a positive or a negative slope. So there we go. So I would say it's not increasing, it's not decreasing. X-intercept, does that constant cross the x-axis at all? And that one does not. So there's no x-intercept. And then the y-intercept, that line is crossing the y-axis at 1. Okay, whew. You made it through your first lesson in Algebra 2, and let's work on shorter lessons moving forward. Great goal for all of us.